It's a super pleasure to see you guys. I don't know many of you, but I'm really excited to talk to you. So I've got extremely fond memories. I was a graduate of the physics program in '99. Um, One of the things I liked the most about the physics program was the faculty. Being able to hang out here, and it wasn't just the physics faculty, because we kind of brought all the STEM kind of people together. There was math, there was engineering, and others. And I got to be inspired by people's lives. And I got to see faith in action. I got to see the intersection of science with real life. And I really fell in love with physics and just learning at Andrews. Physics club was a lot of fun. I don't know if you have that now. The physics labs, the advanced labs, was probably my favorite class on earth ever, where we actually got to invent our own labs and try them out. It was inspiring and opened my mind to science in an incredible way. And then the physics on Rye, I don't know if you guys, what you guys call it now, but on Friday,
That's what eigen is.
Eigen, okay. And then we had the evening ones, Friday nights, where we would sing together, we would hang out, and it was just an incredibly fun experience. So I'm really glad to see the next generation of students in everything and all the related areas around STEM. Whoever's here, really great to have you here. So what I thought I'd do is I'd tell you a little bit about my journey, probably 10, 15 minutes, ask questions anytime. I'll tell you a little bit about the center I'm working with right now, because it's really exciting and there's some really cool vignettes I want to run through, because I think it's just worth you guys hearing about. And then the last part is kind of an AMA, ask me anything part, where I will hang around. I've got a hard stop at 2, but I will hang around, answer questions if you want to know my, anything that I can actually answer. So, baking bread would be off the table, for example, but a lot of other things could be in, but I'd be glad to chat about whatever. So with that, let me tell you a little bit about myself. And like I said, and I'm going to say this, remind you multiple times, use chat, ask questions, whatever you want, whatever medium works the best. If you want to start doing smoke signals, don't burn anything, but just make sure I can have a good view of the smoke so I can read what you're saying. So with that, a little bit about myself. I went to Andrews University. I was there for 6 years. I pretty much tried every single degree at Andrews. Everything from political philosophy to computer science to physics. I smelled every rose that was available to me. I had an incredible time. I was in the honors program and just sucked it all in. Lived in Spain for a while, went to Jordan and did the Badamba Plains project. Tried everything and just had a fantastic time. So I was a super curious learner, but if you asked anyone who knew me, I was probably not the most disciplined learner. I kind of was like one of those crazy caricatures of a student. I just kind of was everywhere. But I learned a lot and I got kickstarted. After Andrews, I got into a PhD program at University of Virginia. They really knocked some sense into me, some additional sense, because I realized that they didn't care if I failed out. So I actually had to turn everything in on time. I had to learn what I needed to learn. And so with a few bruises the first quarter or semester, I finally started to learn, and it took me about 6 years, and I'm still learning this, about how to actually focus and get solutions done. And that's really what UVA, the PhD program, did. I was working on a problem that no one had been able to solve for like 13 years, doing this mathematical modeling. And I realized that I could just focus. This is where my faith went in. I could, faith and focus, I could work, I could get stuff done, I could solve problems, and then I could go to the next problem. And that technique that I learned in graduate school has served me well everywhere I've gone since, because it's just how you get stuff done. I then went to work for the US Army. I worked in decision support and totally fell in love with helping people make decisions with data. At the time, it was just an analysis job. Nowadays, it would be called a data scientist. We didn't call it back then. It didn't have that name back then. But I basically learned how to take a massive amounts of data, run through it, run multiple scenarios, be able to lay out the distribution of options and say, if you do this, you probably have a 30% chance of failure, but it's worth it. This one's riskier. And I would lay out all these analyses for people making decisions about investment, about national security issues, about collaborations. Totally exciting job. But I learned how important data was to use in decision making, and when it wasn't very useful, I learned some program management skills. I learned when it's time to be quiet and when it's time not to give details. Not because you're trying to hide anything, but you just need to shut up because people are thinking and they need to think through stuff. And so you need to give them what they need when they need it, because otherwise they're just overwhelmed with signal. So that was really helpful. Then after that, I went to work for the the Intelligence Advanced Research Project activity, which is a high risk, high payoff funding agency. I learned big boy project management when you have multiple tens of millions of dollars in play, or even more, hundreds of millions, where you're trying to push the frontier of research open so that you could get more capabilities in an applied way. You know, test and evaluation was critical there. I learned how to manage groups of 100 people or so. That was crazy hard, but eventually learned how to work on that. And then learned how to not do work myself. Like, I could do this better, but it's better that I not work on this and let someone else do it. And so that delegation part was a really important part. So the next I went to a Department of Homeland Security. I became the deputy chief scientist and the chief analytics officer. I managed portfolios of projects. I learned what it's like to be hated by everybody, which is not my preferred state. When people want to take your life, not because not necessarily kill you, but they'd really like to see you not be around because you're in their way. You're stopping their programs. They're scared of you because you'll kill their programs, and all these kind of things. So that was a lot of personal dynamic learning, but that really helped me learn how to work in that context of where you're still making progress, but not everyone loves you. Then I worked for the Chan Zuckerberg Initiative, where I was director of an analysis. That was when I interviewed, they had 25 people. The Chan Zuckerberg Initiative is run by Mark Zuckerberg and Priscilla Chan. I don't know if those guy who started Facebook. And so what we did is they gave 99% of their money wealth away, and we were in charge with spending that money to advance and make the world a better place to live in. So I did a lot of analysis. I did product management, worked with product managers or software engineers in the heart of Silicon Valley, and we developed a lot of tools that were supposed to help humankind. And I think they're starting to. But I learned how to hire. I think I was involved in like 100 hirings. So I learned about how to hire, how to evaluate people's capabilities, which was super fun and interesting. And then the last place I'm at right now is at Georgetown. I'm a research faculty member there, and I'm the director of data science, and I lead a lot of research, which we're working. We're philanthropically funded, and I'll tell you a little bit more about that. But it's been an exciting opportunity to actually back into the decision-making place that I have a real love for. Anyway, so that's just a quick summary about me. Any questions before anything else? Any questions you have about the journey, career options, or anything like that? You can use chat if that's safer.
I'm going to ask a loaded question. How much of this was skill and how much of it was God's guidance / luck?
Well, I think we can put them into 3 categories. I'll separate God's guidance and luck. In terms of skill, I have very little. I know very little. I'm not very eloquent as a person. I feel like everything, I'm kind of like a stumbly, mumbly person. But I feel like when I have a purpose, God blesses, and I can actually make sense and do useful stuff. In terms of the other part, I wanted to be a professor. That's all I wanted ever to be. That was my whole goal for going to get a PhD. Why else would I put myself through so much pain and anguish and grief and tears? And so that's what I thought I would do. And that door got shut so many times, so sadly. And I felt like God very much opened the job to work in something that I had never considered, working for the U.S. government as an analyst, working in intelligence for and being an intelligence analyst and having security clearances and secrets and all that kind of. It was terrifying because that's not what I wanted to do. But those doors kept opening in every single career path. When I got a chance to work at Chan Zuckerberg Initiative, it was weird because most of the people who worked there were like people that everyone knew. I was an unknown person, but they wanted me anyway because I developed some technology that they needed. But so it's very much God blessings, and then there's luck. There's always a bit of a roll die of the die. I mean, I handed in my resume at UVA, and 450 people, what in the world was in my resume that picked my resume over those other 450 more qualified people? I have no idea. But it was a combination of luck and divine blessing. I don't know. Did I answer your question? I'm not, I kind of danced all around it.
No, you did. I just wanted to lay out a little bit to some people that sometimes God just has to guide.
Yeah, no kidding. Well, I don't see any chats. Please feel free to do more, but I will jump right in. Let me share my screen and tell you a little bit about the Center for Security and Emerging Technology and tell you some stories, and then we'll go from there. I'm going to leave it in presentation mode because I'm going to hop around just because I'm ADD like that. So let me just set up here just a second. Okay, can everyone see the screen? Thumbs up. Okay, hot dog. Let's charge. So I'm the director of data science. When we started the organization, there was 2 of us. My friend Jason Matheny and I started this. We wrote a grant request for $50 million and they gave it to us. It's an unusual process that we got there. And we basically started a philanthropically funded research center that was designed to work at the intersection of emerging technology and security. So our goal is to connect policymakers. When I say policymakers, I'm talking about like Congress, judges, executive branch folks, international bodies, people who are making decisions about emerging technologies, particularly as it relates to AI. But they're thinking about, what's the security risk? How could this represent an existential risk to humanity? How would we deal with this? How would we be able to handle issues related to immigration or other things? I'll talk about some more examples. We're nonpartisan. We work very hard to be able to walk and talk with people of both sides of the aisles and those with no seating in the aisle, or maybe the people sitting in the aisle as well as the people sitting on either side of it. We are fact-based in the sense that we're trying to provide data that people don't necessarily have and be able to help inform decisions that they need to answer quickly with the best data available. And we are AI and ML is machine learning is where we're focusing right now. So we study the security impacts of what is going on. We deliver these findings. We do some academic work, but we don't reward ourselves for papers. We're not about being like fancy pants publisher in Nature or Science. We just don't care. If we get that, great, but that's not really what we're here for. We're here to truly make an impact on policymakers. And one of the biggest issues in science is the scientists really good at running good tests, communicating to their peers, but they're not always so good at communicating with policymakers to say, this is why this is important and why this is more important than other things you could be exploring, and why we need to take action now. So we have a lot of communication roles. So to do this, we've had to, well, I'll tell you a little bit about how we've staffed the organization to make that possible. We received 5 years of funding. We're not taking money from the government and we're not taking money from corporations. And this allows us to be more straightforward with our the people we're supporting. And we're not, because when you're taking money from somebody, it's hard not to tell them what they want to hear, especially when they won't give you more money if you told them last time what they didn't want to hear. So this whole dynamic, money really warps truth, speaking truth to power. And so we've been able to step out of that, that loop so that we can speak truth to power, tell them what they might not want to hear, but do it with good data, good evidence, and not have to worry about lunch tomorrow because we just ticked off the rich person who's going to feed us tomorrow. Okay, so how did we manage to develop a team? So in 2018, Jason and I were the only 2 employees. We now have about, 60-ish full-time employees, plus about 30 students or so. And we have a lot of volunteers and other things. So we've grown quickly and we've created a team that had multiple skills. So because communication is so important, we have people who are political scientists, lawyers, who are really aware of the policy issues of immigration or intellectual property or safety of AI systems, how to design AI safe systems. but they're communicators. And that's like 2/3 of the team. And then another third is the data scientists, the analysts, the software engineers, the survey capable people who are really good at research methods, and then translators, because we do a lot of work in national security. So a lot of work is not in English. So we have to translate a large amount of content from Chinese, for example, into English, or from Russian to English. This is supported by research analysts and students, which are part of this 2/3, and then this dark blue over here is the 1/3. We've hired distinguished fellows and people who have a lot of experience in government so that they can help guide the messaging to make sure we're landing that messaging well. But that's kind of how we've managed to navigate this, and it's very unique. There's very few organizations in DC who have this combination of technical expertise and people who can like rumble with the data in a useful way, but also be able to understand the policymaking context, and also be able to communicate it in a way that is not silly. So I just saw some comments come in, and I will definitely get to those. I will get to the COVID one, and just at the end, we'll talk about some of the work we did there. And remember to log your attendance on Learning Hub and the passwords data, just in case anyone wasn't paying attention. Great. Okay, so that's the organization. So what are we working on? We have 3 major lines of research. We're do the foundations of AI, because for artificial intelligence to actually work and be positively impacting society, or even negatively, you need talent. You need people who have the skills to implement machine learning algorithms, to test them, to make sure they work the way we think they do, and then be able to deploy them in the environment that they're needed. Investment, obviously, to make anything run, you need money or resources. You need compute. You need a lot of compute to be able to, I don't know if you're familiar with GPT-3 and some of these models. I mean, they're like many millions of dollars of compute just to be able to train the models and be able to make them work. And then data. A lot of our machine learning systems require a fair amount of data, but there's systems that are self-learning, like reinforcement learning, that can learn from their own interactions and collect the data that way to be able to stay upright, or manipulate a Rubik's Cube, or play Go or chess or anything like that. And then this other element of foundations in the first of the 3 bins is algorithms and models. So this is what we traditionally think of as like science, the methods that are being developed, they're being validated, and all that stuff. So that's foundation. So we talk about the foundations that are necessary. How would you compare China's capability in these areas versus the US's or Norway's, or so you can do comparative studies using these foundational skills. You can look at the change in talent, access to talent within, Berrien Springs, Michigan versus San Francisco, California, and you can see, well, where the hubs are for the capabilities and what kind of track you have over time. So that's track 1. Hopefully that made sense. Secondly, the application. So for a policymaker to care, they actually have to know why this technology is being developed. Just because they developed a fancy algorithm that has, a loss function that performs 2.6% better than the last one, that's pretty awesome. But a policymaker is going to go, huh, I don't know what you mean. Why do I care? But if you say, oh, wait, this is applied to a system for image detection that's used in self-driving cars. Oh, okay, now I understand why I care. And then you can say, oh, but it's also used for image facial recognition. Oh, that's helpful too. Oh, that's also used in this other context of, processing images for detection of, cancer tumors. And oh, okay, now I really get it. Okay, I see why this is relevant. So we're looking at cyber applications, looking for AI and cyber defense and cyber offense. This is a big destabilizer because it allows for cyber attacks to be run at a much faster speed. Defense applications, so military, people get all excited about lethal autonomous weapons, and there's reason to get excited about that. But there's a lot of application like predictive maintenance systems for rotor-based aircraft. That's actually really important because in a desert, those helicopters start to fall apart. But if you can say you've got 2 more flight hours before there's a 70% chance that your helicopter is going to fly apart, then you can actually pull that system out and do the predictive maintenance and then put it back in, and you have less bad things happening when you're in the air in the desert, for example, or over some other location. And then we forecast future applications, seeing, where is this technology moving and what is it likely to disrupt? And we'll talk a little bit about manufacturing and other things like that, where we're seeing a lot of changes in artificial intelligence and that insertion of that technology that's changing a lot of how the world could be working or is working and could be working. So, okay, so now I've got two tracks. I've talked about foundation, I've talked about applications, and I've talked about levers. So the third one is alliances and diplomacy. So the US, we've recently had a president who was very fond of the US being able to go it alone. And there are times in which that's a good call. However, in AI, artificial intelligence, that's not as productive, because to be able to make AI systems go, you need compute, and you need cutting edge compute. And if you say, well, where's the foundries that make those semiconductor devices? Well, a lot of those are in Taiwan and Singapore. The US doesn't have very much of that capability. So we could get all excited about us controlling the future of semiconductor development, but we'd have to take into account where the foundries are. Or if you have to actually have equipment, if you're going to set up $1 billion foundry, you actually have to have equipment to make sure the systems you build are actually working like you think. And guess who makes those? Well, those are Norway. So any kind of collaboration or any kind of policy change, you actually have to bring your Singaporeans, your Taiwanese, your Japanese, your Norwegians, and you have to bring them all together so that you actually work. Also, if the US wants to attract students, Canada wants to attract students too. They've got some fantastic AI programs in Canada. So we need to make sure we're working together if we're going to impact positively the world's future as it relates to AI. Standards and testing is critical for AI systems. I've seen a lot of marketing materials that say, oh, look, this wonderful facial recognition system that we've tested on a driver's license will help you operate surveillance systems. Well, that's actually true, because a camera that on your doorbell that sees some FedEx person dropping some package off at your door is a very different quality of a camera than a driver's license picture or something like that. Anyway, the point is you need to understand testings and evaluations and makes you work. And then the trade and industry has to be work out. I spend a lot of time on this because I feel like this is really important context, not only for your own technology development. So if you know your next stages in your career, if you take a technical approach, you might be working on foundations, but you are the talent, and you need to understand where you fit in that equation. You need to understand where the investment is in this area, because that will help you choose career fields that are likely to keep growing. You need to understand these other elements. So this is more than just AI, but this is the space that is relevant. Okay, so I'll truck along here. You have the extreme pleasure of being able to read more of our products. I'll drop a couple messages in the chat so you can see our reports. If you're whoops, as I reformat my slides, just a second here. So there's translations, reports. You can there's even a forecasting environment where you can actually answer questions on the future of technologies. And then we aggregate those judgments and use that with our data to help answer questions about what's happening in the future. I'll talk about that if we have time in a minute. Okay, so that's who we are. Just a quick digression into the data. I'm a data dude, and I really, really like data. And so just to give you a sense, we've collected data from 17 different data providers. So we have, I think, about 360 million unique articles. So we have the scholarly literature from around the world. Oh, not unique, sorry, duplicated. I think the unique is about 260 now million unique articles in English, Chinese, Russian. So we work in multiple languages. We have information on 5 million corporations. We have government and financial transactions. We have about 250 million job postings. We have about 450 million career histories. We have news from around the world. We have business intelligence data from semiconductor industry, from the robotics industry, for all these different. So we've fused all this data together. And it's about 28 terabytes single copy text. So that's not a lot of data, but it's enough to keep you up at night trying to read. I think about 14 billion pages or so. And then we improve that data. We have every year we spend about 20,000 hours of annotator time, improving the data. Like, for example, organization entity resolution work. We extract text to train up our models for extracting new features from the text. for fusing the data. And so that requires a lot of human annotation time. And then as of October, we has spent well over 100 years of computation. We launched a lot of jobs. I remember one of our training models, which I'll talk about, I think cost about, I don't know, $20,000 to train just of compute time. And takes a lot of work. And so that's the other thing. So to be able to do the kind of work we're doing, we need the data, we need the expertise, which we've hired, and then we have to have a lot of compute time, plus the annotators continually updating our models and helping us to do this work. Anyway, so that gives a quick sense of CSET. Yeah, like I said, we have organizational entity resolution that connects all these different types of data, worldwide funding, worldwide talent, technical text, dissertations, theses, all this kind of work, patents. And then we have human annotation. We do targeted surveys. So we'll collect data, then we'll actually ask all those individuals to answer questions about their career trajectories. And that will help us better understand what's happening in the space. Anyway, I just dumped a ton of information. Let me pause for a second and see if there's any questions. I see Eric has one. I was curious about the implications and changes in policy regarding AI in response to China's development of well. Ooh, that's exactly one of the big drivers here. So we're actually looking at the research emphasis areas that are happening. I'll talk about in a little bit about what's going on by the security forces in China. Lots of very interesting surveillance work, which is a little, and their attempt to export that technology around the world, which is a little frightening to me. And we'll talk a little bit about it. So this is a big driver, Eric. If I don't fully answer your question, well, I don't think I'll ever fully answer it, but come back and I'll see if I answered it in just a minute. I see another one, Future of Life Institute, worry about the existential threat to humanity that AI could propose, and how could we best align AI to our values and norms, which are obviously a complex landscape. Yeah, I totally agree. So yeah, very interesting. This, we work with a lot of these groups. For example, Oxford has a group that we work with very closely, Cambridge. And then we talk a lot about in terms of AI safety, how do you design objective functions or loss functions that are not going to go off the rails in a way that could put an existential risk. We talk about a little bit about AGI. And the general artificial intelligence. So we're definitely exploring some of these dimensions, and some of our products are actually addressing these questions. So we work with policymakers to help understand, to make sure that they align their investments so that these kind of principles are taken into account when they're deploying, like, for example, with the Department of Defense, some of their military systems, to make sure they're thinking through these principles. So yes, very much central to what we're doing. Okay, so let me give just a few examples in a few minutes, and then we'll jump around. So one of the tasks I've been working with the OECD, which is an organization, multi-party organization for the world's largest economies. And what we do is I'm lead one of the working groups of trying to figure out how to classify AI systems. So imagine back in biology class, you get you're supposed to walk around and be able to identify birds. Well, how do you identify the birds? Okay, well, that one's got, this certain color marking. Look at that bill, look at the length of the legs. So for AI systems, what kind of framework would we want to do to be able to differentiate between AI systems? Because policymakers very easily gravitate toward, oh, it's AI, and they stop and they feel like they've just characterized the issue. The problem is AI is a little bit more complex than that. There's different kinds, just like the birds. There's some big birds and there's some little birds. There's some big AI systems, little AI systems. Some of them, like to eat flesh. Some of them just are happy to eat seeds. Understanding the difference between these systems is really, so for example, the AI system. So in the top left here, this is a water system, water treatment control room using AI to release chemicals into the water to optimize the treatment. You got your self-driving cars, you've got predictive maintenance on assembly lines, and you've got recommender systems like on YouTube for kids' videos, which went horribly for a while. I don't know if anyone is the product of bad recommendations on YouTube for kids. It can get pretty traumatic pretty quickly. At least they claim they fixed it, but that was a problem that they had. So different types of AI systems raise different policy questions. So understanding that. So what we're doing right now is Yeah, this is just examples of bad things that I just mentioned, and many others. There's a database we're collecting of like when AI systems go wrong, and we're actually extracting information about those systems so that we can start to characterize the risks that these AI systems are imposing and why they're failing. Because we might find that, for example, generative models, things that generate text or generate voice, maybe there was a couple days ago, there was a paper that was published where generated an image, and it was terribly sexist. I mean, just horrible, because it was using the data that was widely available, and understanding that a generative model might impose different risks than a discriminative model, for example. Anyway, hopping along. So what we did is we had four parts of the framework that we defined. And the one, first of all, was understanding the context in which the AI system's operating. This, which includes the sector where it was designed, the impact scale. We'll talk about that in just a second. The next dimension was the data and input. How is this information being collected? Is there PII and personally identifiable information or other things like that? A third dimension is the AI model itself, which I'll talk. How does it learn its capabilities? Is it learning because a human marked up data for it, or is it learning from its own experiences? And then the fourth one is the tasks and outputs. So what we did then is, let me just give a few examples. So we picked a couple different characters. This is just an example of sector and deployment. Critical function, is this health and safety? Is it essential to the economic and social services? Who are the users? Are they AI experts or non-experts? How is the data collected? What is the domain of the data? Is it personal, proprietary? Is it publicly available? How did it acquire its capabilities? Did it learn from people, or did it learn from system experiences, or was data provided to it? The system task that it's involved in, the level of action autonomy. This is really important. Is the human in the loop, is it out of the loop, or is it on the loop where it's kind of in the middle, where a human's involved with actually making the final decision, but the computer's making recommendations? So we can pick just a few examples to highlight this. So here's AlphaGo Zero, widely popular and well-known AI system. It's in the arts and entertainment and recreation sector. It has no critical function because, as far as we know, Go does not actually impact human life. Other than, well, anyway, we won't go into that. But system users were written as AI experts. Now they're starting to deploy it to more, there's some systems that are similar, although AlphaGo has not yet, to my knowledge, been released to the public. Data collection, automated source. So this is because it's reinforcement learning. It's learning from the data that it gets from playing the games, as opposed to one where humans are marking up the data. It's proprietary because that's how they built their own system. And they acquired, there was some public, they did load, but not AlphaGo Zero. Some of the other ones used previous game history, but AlphaGo Zero learned everything from scratch. It learned from system experience. It's a goal-driven optimization system. And it's a high level of action autonomy if you consider playing the game the domain that you're working within. So this gives you a sense of what AlphaGo. I'll give you one other example. Let's see, GPT-3, or let's do a credit scoring system here. So this is financial and insurance activities, where it's giving scores of it's basically using AI to predict your safeness of loaning money to you. It's technically, this is actually a legal document, so it's not a critical function in the current it is a critical function, in the legal definition, because of economic services it provides. Primary users are not AI experts. In fact, it's a little frightening how some of these systems get deployed. Human and automated sources, it's a mix, which actually makes it a little harder sometimes to know exactly the traceability of how this classification system came up with. There's usually a mix of proprietary and public data. It learns from provided data. So once again, if the data is not provided about you that's accurate, it will learn things about you that probably aren't true. It's a forecasting driven system, and it's a medium action autonomy. However, in some implementations, it's actually almost entirely automated, which is a little even more frightening, because the computers just, because they want to get rapid responses. Anyway, so this is the classification system we're starting to define, and we're pushing this out to the EU and US government, and other corporations are starting to explore this classification framework we've developed so that they can start to characterize risk and understand what the risk of this AI system is. It's a super exciting application. It's bleeding edge right now. We're just presenting this to these organizations, and we've been it's gotten a lot of people excited. So that's kind of the first quick check. I'm looking at questions. So there's a question. Yes, we do work with, I'm also on the Global Partnership for AI, which is a G7 group that's working on data governance rules for people who use data for AI systems. And that's where I spend a lot more of my time about the collection of data and how privacy and security is maintained. So definitely relevant. Happy to take more questions about this. Let's see here. Yeah, no kidding. For example, the Aegis military system launches a missile, launches a anti-missile defense system with no human interaction, because if the human was involved, there would be no way of stopping it. And actually, mines are essentially autonomous weapon systems too, because they're dumb, they're frighteningly dumb, and they'll blow up whoever steps on them. But there's a lot of examples of these defense applications that pre-AI, and now AI just complicates it even more. So let's see here. I've 1:11. I've got about 20 more minutes of joy to dispense. So let me jump really quickly into another topic. So quick question that came up. Do you present information based on who you are talking to? So we try to speak truth to power, and that truth needs to be uniformly true. We're not gonna tailor that. However, we do tailor our communication strategy to who. So if you're talking to a Congress person, they've got different equities and different levers that they can push. So we tend to emphasize the things that they can do about it. While if you're talking to a head of Department of Energy, Office of Science, you have a different emphasis of what you're talking about, because you understand the context. So yes, we're very context aware, but we try to keep a uniform message of that is not inconsistent across those contexts. Good question. It's really important as data scientists. If any of you ever become a data scientist, this is really important. You have to be really grounded on what you believe is true, because it's really easy to convince yourself that truth is a certain way, especially when you know you can get a promotion if the truth goes this way. But you really have to ground yourself and be willing to take the pain of people not liking your messaging, get the truth, but then tailor that message to the context so that the people who are taking that information can really use it. Okay, so let me jump into a really fun space. So what we did is we've got the world scientific literature. We have over 90% of it. And since we're dealing with emerging technologies, we need to know what's happening. What we've done is, so it's about 382 million documents. About 108 of them are high enough quality for us to use in our citation graph. And we fuse data from China, from Microsoft Academic Graph, from Dimensions, from Web of Science. We put all this data together, and we're able to then break down what's happening around the world. So, we have about 31 million documents that are authored by Chinese authors, about 60 million from the EU, about 10 million from Japan, about 56 million from the US. And then we can start looking at this data. We create this graph. And now with this graph, we can start to, because these research clusters are tightly defined groups of researchers and research around that are centered around each of these problems. So, reinforcement learning is actually too big, but reinforcement learning for robotic hand manipulation. Now that's a research cluster that will help you understand what's going on in this area. You can see what the trend is, how much research attention it's getting, or you can see for, sentiment analysis for the diagnosis of mental illness or depression. That's a whole nice, and it's very fast growing one of research that is using natural language processing techniques. So each of those dots, essentially each of those topics. So we do this for the whole world of topics. So biology to social sciences. This little vestigial organ here is to humanities. No disrespect, but it's a funny little place to live in the worlds of scientific literature. Here's your social science. Here's your dark blue, your physics, mathematics. purple, I guess. And then your computer science is this lilac color, because whenever you think of computer science, my mind immediately says lilac. And then there's a light blue and the dark blue, material science and chemistry. Anyway, this proximity to each other represents how similar these disciplines are each other based on how they cite each other, which is why humanities is not a frequent citer of physics, which is why it's so far from physics. They do happen sometimes, but it's just a quick overview. So what we did is we took all this literature, and now we can tell stories about what research areas are growing, which ones are getting more attention, where is China working on that US is not, where are authoritarian states spending emphasis in AI, and where are the democratic states spending time looking at AI? Really important questions that a lot of people don't have access to. But to be able to do this, we actually had to build a classifier of defining what AI is. And I don't know if anyone has been following AI, but it's really hard to nail down what the definition is. It's, machine learning is diverse. And so what we did is we built this AI ML classification system. So we used archive, which is a preprint archive that comes labeled, and the human, when you upload a manuscript to archive, you say, I think this is what it's about. And then an editor looks at it and says, yes, I agree with you, or I disagree with you, and they reclassify it. What this has done is it's created just a labeled data set that we can now classify computer vision, natural language processing, robotics, or other kinds of AI techniques using this wonderful training set. So we used it, and we were able to define these types of AI systems with a BERT. It's a transformer-based, I won't get into all the details, but it's really exciting extension of natural language processing that happened late 2018, early 2019, totally transformed natural language processing. I mean, it's a whole new world out there. Really quite exciting. So we used this model, we trained it, we were able to get precision recall. So these are measures of how good things work. And we were able to beat most other systems. In fact, one of the most powerful reality is, before, people used to define AI as like a whole list of keywords. Well, if it's talking about, SVMs, it must be machine learning. If it's talking about, sorry, that was support vector machines. I can get acronymy really easily. Or if it's working on a particular type of reinforcement learning, so they had this long list of keywords, and we compare these keywords versus our BERT-based transformer, and we can got a much better performance. And so that's how we define what AI is. Once we have this, we can figure out what's going on in that beautiful graph I showed you earlier. This is where all the AI papers, and we took this roughly 1,000 research communities, and we can start answering questions like, which research is hot? What should we invest in? Where are the most prestigious researchers going? What are the experts in each of these areas? And when do you exit a research area because it's dying off, or other things like that? We're able to make forecasts about these research, and we actually can score forecasts. So I won't go into the forecasting model, but we have a pretty simple model. We have a paper about it if you're interested in it. But basically, we're able to make real reliable forecasts. Obviously, future is always a little murky about a target year 3 years from now, and we can say which research clusters are moving the most fast. So, for example, we made a forecast for January 2023. And we were saying the ones that we believe will be growing the fastest is region-based object detection. So this is your fast RCNNs and YOLO models. You only look once, single shot type learning, super exciting area of machine learning. But they're using it on computer vision, and it has a lot of application in image processing. It's the fastest growing based on this forecast. Then we have deep learning on graphs, which is really important for drug discovery and other things, because once you lay data into a graph, you can actually start to use deep learning to learn connections and start to predict properties about drugs, medical treatment drugs, or other kinds of things that uses that graph. Generative models obviously is pretty exciting, and this is already taking off. In image synthesis, data augmentation, being able to use models to generate text. Anyway, sorry, I don't know how much technical introduction you had to AI, so I just might have totally put some people to sleep, but it's, yeah, YOLO does have a new meaning. But it's so cool to be able to track this and be able to see what's going on. So here's an example of computer vision region-based object detection, and you can see the neighboring communities that are being that are all growing together. And so right now, this region-based object detection is growing at 99.99 percentile, which means you really can't get another research area that's growing much faster. And I think we have about 250,000 of them. And it's predicted to maintain that kind of growth. So this is now, we're basically can start to talk to our DARPAs and our funding agencies, give them context about what kind of, where they're putting their money, and give them context about what's happening and who's spending money. So for example, who's spending money in this area? The Ministry of Science and Technology in China, the National Natural Science Foundation in China, the US NSF, the European Commission, the Ministry of Science, once again, in China, and then NVIDIA. So this now gives you a sense of where the money's coming from that's driving this innovation, that's paying for this expensive work. And it gives you a really, anyway, we can go way deeper into it, but this is super fun. I will jump along to another story. I'm gonna skip the crowd-based forecasting. If you want, we can come back to that. We're also doing some really interesting policy work where we're saying, if you were to take a authoritarian country, there's a, COVID has really sanitized the willingness of nations to adopt what has previously been viewed as an authoritarian approach to ML, where you're basically enabling a state to keep tabs over an entire country, to be able to control life and that kind of thing. And that's generally been viewed as bad, but under a pandemic setting, there's actually reasons to have some of these capabilities. And so countries that had previously said, oh, we don't want to talk to you, China, are willing to buy their technology, which is actually a little frightening because it's developed and there's no attempt to protect privacy. And this is generally a bad state for humankind, in my personal opinion. So Tim Wong here wrote this really interesting piece that basically said, if we're going to invent AI systems and we want to promote democratic values, the kinds of technology we should be investing in are reducing dependence on data. So, reinforcement type learning systems are better because they're not feeding off the masses in the same way. We need to explore more simulated learning or zero-shot learning. It seems a better approach. Second one is foster techniques that support democratic legitimacy, enable civil participation, public accountability, review. The more we require our systems to meet those standards, the better it is for humanity and particularly democratic values. Invest in machine learning interpretability, fairness, and privacy are really important. Challenge this. So when anyone uses systems that are controlling their population, challenge it, break their system, make it, show how to defeat it, make that publicly available so that people who want to use systems in a bad way have a harder time. It increases the expense of operating that. So this is an important aspect, especially as you're thinking about what you want to work on next. If you're interested in the machine learning space, reading this paper by Tim is really worthwhile because it gets you thinking about where you should spend, not just because it's technically cool, because a lot of this is technically cool, but what could actually make a difference in society. Jumping into another thing, because I'm just like dragging you around the merry-go-round here. Hopefully you're not too sick with, but let's move on to interest in Chinese. So what I did is I looked at the People's Liberation Army, the Ministry of Public Security, the People's Armed Police, and the Ministry of State Security, and looked at all the research that they published in Chinese. And this is the pinky russet color, whatever. The blue one there is in what they publish in English. So you see, if you want to know what's happening from these security organizations, you need to look at what's happening in Chinese. So we spent a lot of time working at China, and we were able to start to look at the work that they were participating in. And what we found was, this is the Ministry of MPS, Public Safety. Is it Public Safety? I think I just messed that. Public Security, sorry, yeah. So computer vision is their primary area of research that they work in. The People's Armed Police, likewise, a little bit in robotics, but a lot more here. And these are research clusters, by the way. This is not papers. These are like communities that they're participating in. People's Liberation Army were more interested in things like path planning, targeting, multi-path tracking, intrusion detection for computer network systems. Steganography was a huge one, particularly for the People's Armed Police, where, I don't have has anyone heard of what steganography is? So this is when you hide messages in images. And they're spending a lot of time trying to figure out how to intercept images that have messages and break them and then go get the people who were communicating secretly among their own population. It's very much a surveillance approach that they're taking. And you find that true for a lot of the work that the the PRC, People's Republic of China, are working on. Target detection, object detection, imaging, facial recognition, gate detection, vehicle detection, forgery. So some of it is straight up police, but a lot of it's just trying to figure out how to keep tabs on their own people, which is once again markedly different from even in your most pessimistic world. The US is nothing like this in terms of how we are developing AI systems. Anyway, so this gives you a sense. We also are looking at the labor market in data science. This is relevant to you guys. I put a list of resources. Birchworks is an incredible place if you're interested in looking at the job market in data science. They publish these really cool reports to show you where people are moving, how much they get paid, what kind of expertise they need, what kind of tools they use. We have a bunch of products on the US AI workforce, where people are working. So take a look if you want. But we're finding that there's this team of people that are required to make AI systems work. You need a commercial team to be able to figure out how to make that a product. We need the core capability, the people who can make those algorithms sing. And you need a product team that understands how to refine it, take feedback, and be able to drive the development in a way that makes it useful. User experience people, compliance. Anyway, so we're now tracking 330 million job postings from 4.7 million employers, and we're looking at all the different data that's going on in data science and machine learning, and we're starting to look at, what are the top areas where people are studying, what the trends are, so we can better understand the job market. The last thing I'll say is we've also on March last year, I got a call from the White House saying, could you help us? Our experts are getting overwhelmed. We don't have enough knowledge about what's happening with COVID. It's changing too fast, and people answering questions is just too hard, and they're not staying current with what's everything happening. Could you create a database that would be publicly available, that would make everything that we're learning from COVID-19 research during the pandemic, make it publicly accessible? So I called up some of my friends at CZI, at the Allen Institute for AI, which is an incredible place doing wonderful research in AI, and a number of other places. Microsoft was another place I called, and we put together a project. And 10 days later, we released the CORD-19 data set, which is publicly available, of full text of pretty much all the research that's going on in COVID-19. It's updated daily. I think it used to be weekly. I think they've updated it daily. And we created that data. We published a paper on it to make it so it was available, ran a competition on Kaggle. And I think 600 papers have cited this data, have used this data, and about 150 have made direct citations. Really quite an exciting project where we collaborated and used open data to try to kickstart the development of new algorithms so that people could better track and answer questions about what's happening with COVID. So the last thing is, you can go to our website, you can sign up for our newsletter and see the stuff we want. It's a very interesting topic, and I'm going to stop sharing, and I want to make sure we have a discussion, so I am stopping talking.